Section 7.1, opening statements. Define and identify statements. So there's a couple types of statements. One of them is a factual statement. So like you are stating a fact. You have to pass the bar exam to practice law. That is a factual statement. Commands, like telling someone to do something or don't do something. So don't open the door. Opinions. Chocolate cake made with mayonnaise is the best cake ever. That's an opinion. If you've never done that, trust me on that, it's bomb. Questions. So when you ask a question, what time does Muna come on stage? Exclamations. So like, bro, or like, what are you doing? In the objective study of logic, we will use only factual statements. So in chapter 7, we're only going to be talking about factual statements. A statement is a declarative sentence that can be objectively determined to be either true or false, but not both. So a statement literally can only be true or false. The sky is blue. That is true. The sky is purple. That is false. So you have to be able to assign a truth value to each statement. Example 1, decide whether or not each sentence is a statement. If it is a statement, decide whether it is true or false. If not, let's say why not. So dude, those pants rock. That is not a statement. You're just saying, like, you have awesome pants. So, no, that's not a statement. 12 minus 8 equals 5. That is a statement. We're not using words, we're using numbers and values, but that actually is a statement because it's true. It's not only true, but you're saying 12 minus 8 is 5. It is just, that is what it is. It's no opinion. Jimmy Kimmel is the host of The Daily Show. That's not true, but we're saying yes, that is a statement. That is a statement that we're saying. Whether or not it's true or not, that's a different story. But yes, that is a statement because it's not an opinion. It's not anything saying like I like your socks or whatever. It is a statement. Alicia can film in slow-mo with their new phone. That is a statement. We're not saying anything about how cool it is or saying like, oh, like your phone can do that. That's so awesome. That is a statement. When does the party start? That is not a statement. You are asking a question. History is interesting. Well, that's an opinion. History can be interesting. It can be boring. That's up to us. So no, that is not a statement. Define the logical connectives and identify their use. So statements can be classified as simple or compound. A simple statement contains only one idea. Each of the statements in this example are simple. Your jeans are torn. I'm only saying one thing. My dorm room has a pile of books in it. I'm saying one thing. Vero Beach is in Florida. I'm saying one thing. So a simple statement is saying one idea, one thing. A statement like I am taking chemistry this semester and I'm going to get an A, that's a compound statement because it is formed from more than one simple statement. You're combining two things, chem and getting an A. A compound statement is formed by joining two or more simple statements with a connective. There are four basic connectives in logic. And, which is called a conjunction, or, which is a disjunction, if then, which is conditional, and if and only if, which is biconditional. So if you notice here, we had the word and. That word and created a compound statement. So this is a conjunction compound statement. Common synonyms. So a synonym for and, which is a conjunction, so but, moreover, furthermore, also, as well as, in addition, besides, along with. All of that in logic means and. We also have synonyms for or. So alternation, logical sum, union, either, that also means or. If then, hypothetical proposition, material implications, entailment, sufficient condition, inference. So that's a little more complex, but I just wanted to give you synonyms of that. If and only if, equivalently, just in case, exactly when, that's a biconditional. For each compound statement, let's identify the connectives as well as the two simple statements that it connects. So we have, for dinner tomorrow, I plan to cook butter chicken and make fresh naan. So since we have the word and, that's our connective. And And there's a symbol for that. I'm going to teach you the symbols right now. It actually looks like a little A with no line through it. So that's our connective. And our first simple statement is, for dinner tomorrow, I plan to cook butter chicken. And our second simple statement is, make fresh naan. All right, so B. Let's go to Epcot or to Animal Kingdom. So because we see or, we know that this is a compound statement. So that's our connective, or. Or is the connective, and it's actually kind of it's like the opposite of and. So it's literally the opposite of the symbol, or. Our first simple statement is, let's go to Epcot. Our second simple statement is, go to Animal Kingdom. If tickets don't sell out, then I can go to Chapel Roan's concert. So because we see the word then, if you track back, you'll always see if. So we have an if-then statement. If-then statement, the symbol for that is a single arrow. Because you're saying, if you do this, then you do this. So imagine like I'm doing this and the arrow is taking me to the conclusion. Our first simple statement is tickets don't sell out. Our second simple statement is I'm going to go to Chapel's concert. All right, part D. I want you to try this. Pause the video and try. I hope you did. What's great about this is you learn this online at home. Some of you might be in class, but at the end of the day, if you're at home or online, nobody knows what you're doing. I can't see you, only you know. Only you know if you got this right or wrong. So there's no risk in trying. And guess what? It's okay to be wrong. Life is full of being wrong and making choices that aren't the best, but it's what we do to learn from them, and that's what math is. Math is learning from our mistakes. So I will play the new F1 game if and only if they have the new McLaren livery. So I know that this is for sure a compound statement because I have two ideas and I have the phrase if and only if. So if and only if, sometimes they abbreviate that as IFF, and the symbol for that is a double arrow. I remember double arrow because we have if, so double. Our first simple statement is I will play the new F1 game. My second simple statement is they have to have the new McLaren livery. All right, example 3. Let's classify each statement as a simple or compound. If compound, state the name of the connective used. So we're basically going to look at each statement and determine, is it compound? Is it simple? If it's compound, we're going to say, is it conjunction, conditional, biconditional, stuff like that. So my jacket is both warm and light. Because I see the word and tells me that this is a compound. And because this is a compound, let's identify what kind of compound. It's a conjunction. And is conjunction. Alright, B. This is an informative website. There's no words like and or if then or if and only if. We have no connecting words. Since there's no connecting words, this is just a simple statement, one idea. Alright, C. If it rains tomorrow, I am going windsurfing. This is a compound. You might not see it because you're like, well, where's if then? Where's or? Where's and? Remember the synonyms. So you have to think logically about this. So how do I know for surezies that this is compound? I'm talking about two ideas. The first idea saying if it's raining, I'm going to go windsurfing. So I'm talking about two things, the rain and windsurfing. Now, how do I know which one is this? Is it a compound? Or sorry, is it conditional, biconditional, conjunction, disjunction? We see the word if. If I is another way of saying if then. So this is conditional. Because you're also setting a condition. I'm only going to go to windsurfing if it's raining tomorrow. I want you to try D. Go ahead, pause, try D. I hope you're trying. I do hope you're trying. You gotta do stuff like that in math to learn, especially in this class. So, I am going to eat at Taco Bell or Del Taco today. I know that this is compound because I'm talking about two things, T-Bell and Del Taco. So, I'm going to look for my connective. Or is bringing them together. Since it's or, we know that this is a disjunction. Alright, part E. Yesterday was the deadline to withdraw from the class. I'm only talking about one thing, withdrawing from the class with the deadline. So there's no connectives either. This is just a simple statement. In standard usage, the word then is often omitted from a conditional statement. Instead of if it snow, then I will go skiing, you'll probably just say if it snows, I will go skiing. Quantifiers. In logic, there are words that express the quantity of subjects to which a statement applies. Words such as all, none, or no, and some, those are all quantifiers. So universal quantifiers. All students in the class passed the test, meaning every single student, without exception, passed the test. That's what all means. All means every single one of you. Existential quantifiers. Some students in the class passed the test. So what that actually means is at least one student in the class passed, but not necessarily all of them. Because if you say some, that has to be one or more. That counts. Visualizing quantifiers. So imagine a classroom where the teacher says every student must hand in their homework. That means that the homework rule applies to each and every student. That's the universal version. The existential version, imagine the same classroom where the teacher says at least one student must hand in their homework. That means that it's enough if one student hands it in, even if not everyone else does. The words each, every, and all mean the same things. Likewise, some, there exists, and at least one are considered to be the same and treated that way as well. Let's recognize and write negations of statements. So in logic, negation is a way of expressing that a statement is not true. It essentially reverses the truth value of a given statement. So the simple statement, the sky is blue, to negate that, we would say the sky is not blue. A simple statement, it is raining. To negate that, it is not raining. A statement, all dogs bark. To negate that, we would say not all dogs bark. That means there is at least one dog that does not bark. Be careful when writing statements that contain quantifiers. All are means some, the opposite of that is some are not. Because if you're saying all are, that's every single thing. So you have to say at least one is not happening. None are, the opposite of that is some are, and then vice versa. Some are, the opposite of that is none are, some are not, the opposite is all are. We're going to write the negation of each statement. Everyone is on social media. So that is saying every single person is on social media. So to negate that, we would say some people are not on social media. The opposite of all is some. No person can win the lottery. So we're saying not one single person, nobody. That is saying, that is collecting everybody. We're saying everyone cannot win. So the opposite of that is saying at least one person can win the lottery. All right, some professors have PhDs. So we're saying at least one professor has a PhD. So to negate that, we would say no professors have PhDs. So write statements symbolically and translate symbolic statements back to verbal. So we kind of already talked about these symbols. And it looks like an A, that's called a disjunction, or it's the opposite of and, that's a disjunction. If then is a single arrow, that's conditional, and if and only if is biconditional, and the little squiggly, That means negation. Simple statements in logic are usually denoted with lowercase letters p, q, and r. So let's suppose that P represents the statement I get paid Friday, and Q represents the statement I will go out this weekend. We're going to use these symbols to write the sentence and the symbolic form. So it told us that for A, we want to do a conjunction. So conjunction means and. So what we do is we bring our two simple statements together. We want to do P and Q. P, the little a symbol, Q. So P, that is represented by I get paid Friday. So we just literally write what P represents. It's like saying X equals 3. You can keep it as X or you can plug in 3. So P is I get paid Friday. We have our little symbol and then Q. Q is I will go out this weekend. So I will go out this weekend. We literally write it verbatim what it told us P and Q are. We're just now just putting it together. So for disjunction, that stands for or. So we have P or Q. It told us again that P represents I get paid Friday. We have our connector of or. And then I will go out this weekend. That stood for Q. All right, C, we have a conditional. Conditional stands for if then. That's a single arrow. So we have P single arrow Q. So when we do conditional, we always have to start with if. So if, and then we get to it. So if, that stands for the condition. Then we have P, which is I get paid Friday. And then we have then, and then Q. Q told us that that's represented I will go out this weekend. All right, now we have biconditional. So biconditional is if and only if. So we have P, which represents if I get paid this Friday. We have our connector of if and only if. And then we have Q, which states I will go out this weekend. So let's negate P. To negate P, so P represents I get paid Friday. To negate that, we would say I will not get paid Friday. So this little squiggle means not. All right, so we have squiggle P. So squiggle P means to negate P. So my friend is a football player, we would say my friend is not a football player. All right, let's do B. So B, we have PVQ. PVQ actually stands for P or Q. So we are literally going to write P or Q. So P represents my friend is a football player. And then we have or. And then Q. Q represents my friend is smart. All right, C, we have negation P, double arrow Q. So we have squiggle P, double arrow Q. That's negation P if and only if Q. So we have negation and then P. So to negate P, we would say my friend is not a football player. We have our connective of double arrow. Double arrow stands for if and only if. And then we have Q. So Q is represented by my friend is smart. Do you notice how we're just doing exactly what it's telling us to do? We're just putting words to it. So we're saying negate P. So my friend is not a football player. We have double arrow, if and only if. Then we have Q. My friend is smart. I'm not thinking. I'm just writing exactly what it's telling me to write. What you're learning is what do the symbols actually mean. All right, D. If you are a grammar and English person, logic is not going to be your favorite thing because the way we speak logically and in logic is very different from how we speak in normal English talk. So this one's, it's gonna probably hurt you on the inside, but it's okay. This is just logic, not English. So define the difference in your brain the best you can. So we have squiggle, parentheses, P, and Q. So squiggle means to negate. So we know we need to negate the whole thing. The easiest way to say that is it is not true or it is false. So I'm going to say it is not true. Because that's what a negation symbol means. You're saying not. So it is not true. And then we have comma. The reason why we have a comma is because we have parentheses. You're going to learn more about that. And then just go straight up into it. We have P. So P is my friend is a football player. We have our connector of and. That's a little A symbol. And then it's just telling us to write Q. So Q is my friend is smart.